Good morning to my American, European, Australian, Indian, and the students all over the world. Today we are going to do the subject physics, and in this the topic Newton's laws. We are going to understand about Newton's laws. So the first law of Newton is Newton's first law of motion, and it is for class 12. So Newton's first law of motion: when a body is in motion, it continues to remain in motion. When a body is in rest, it continues to remain in rest. When a body is moving in a particular direction, it continues to move in that particular direction unless an external force is applied to change its present state or direction or the state of rest or motion. It is based on the property inertia. Inertia is the tendency of the body to continue its present state, to resist the change in the present state, and they are of three kinds: inertia of motion, inertia of rest, inertia of direction. So, first one is inertia of direction. When a body is in motion, it continues to remain in motion and it changes its state or comes to rest when an external force is applied to it. The second one is inertia of rest. When a body is in rest, it continues to remain in rest and it changes its state or comes in motion when an external force is applied to it. Then is the inertia of direction. Inertia of direction: when a body is moving in a particular direction, it continues to move in that particular direction unless an external force is applied to change its direction. So now this is the Newton's first law of motion. Now we are coming to the Newton's second law of motion. According to the Newton's second law of motion, the force is directly proportional to the rate of change of momentum of the body. So according to this, it is F is directly proportional to dp upon dt, where p is the momentum which is equal to mv. So F is directly proportional to d upon dt of mv. So F is directly proportional to m is constant, so it is dv upon dt. And so F is directly proportional to m, and this is the acceleration a. So taking a constant, that is k, so it becomes kma. For simplicity, we are taking k equal to 1. So it becomes F is equal to ma. So F equal to ma is our answer. So this is the Newton's second law of motion. F is directly proportional to the rate of change of momentum. So F is directly proportional to d upon dt of mv, where F is directly proportional to m is constant, dv upon dt. dv upon dt is the acceleration, that is a. So F is equal to kma, where k is equal to 1 for simplicity, then F is equal to ma. So if a force F is applied on a body of mass m, then it moves in the direction of the force with an acceleration a. So this is our mathematical statement of Newton's second law of motion. So now we are coming to the Newton's third law of motion. According to Newton's third law of motion, to every action there is an equal and opposite reaction. An action and reaction act on different bodies. We can understand this with the help of an example. The example is, suppose there is a person and this is a boat in which there is a person and it is standing on the edge of the boat in a river. This is the river. You can see this is the boat and this is the person, and this is the river. So the person jumps in the river. So as it jumps, it moves in the forward direction. The person moves in the forward direction, and as a result, the boat moves in the backward direction. So the jumping of the man or the person in the river is the action, and with respect to it, there is a reaction. The boat moves in the backward direction. So this is its reaction. So this is according to the Newton's second law of motion. So this is one of the examples of Newton's second law of motion. Also, there is a gun. You can see there is a gun, and if it is fired, it the bullet moves with a very high velocity in the forward direction. As a result, this is the action. The bullet moves in the forward direction, and the gun moves in the backward direction. There is a with its recoil velocity, and this is its backward direction, and in the backward direction, and it is its recoil velocity due to which it moves backward, and we say it uh, and we say that it is the reaction of the action, and so it is also an example of Newton's second law of motion. So this is about the Newton's second law of motion. So I think you all might have understood these topics. So please watch this video till the end. Subscribe me and press the bell icon. Thank you.